Okay, so this is the after-school review session on Hardy-Weinberg problems for those of you who couldn't make it to after-school tutoring. We just did problem number 1, and problem number 1 is just like number 6 on your homework. I'm going to really quickly go back and recap. It's giving you here this number, so your frequency is 0.36 for your little a genotype. Then you do your P plus Q is equal to 1. So you know that, this is my line is too thick here. So we have to do 0.36 and do the square root of it. This is my P squared value. I'm sorry, my Q squared value. And so I've got to go to Q is equal to 0.6. So this number here is 0.6. Then if my P plus Q is 1, if my Q is 0.6, my P value is going to be 0.4. And then we've got to do homozygous dominant. That's going to be P squared. And so that's going to be, this was supposed to be 0.4 squared. Is that right? Class, are you guys watching? 0.4 times 4 is 1/6. Okay, 16. And then I want to add that to my 2PQ, which we determined was 2 times 0.4 times 0.6 is 0.48. So we would add the 16 to the 0.48 to get this number here. And then how often do we have the dominant traits is completely dominant, so it's those two numbers together. All right, so we're moving on to problem number 2. Sickle cell anemia is an interesting genetic disease. Normal homozygous individuals have normal blood cells that are easily infected with the malarial parasite. Thus, many of these individuals become very ill from the parasite and many die. Individuals homozygous for the sickle cell trait, homozygous recessive, have red blood cells that readily collapse when deoxygenated. Although malaria cannot grow in these red blood cells, individuals often die because of the genetic defect. So you can see here that being homozygous dominant and homozygous recessive are actually not beneficial. Okay, so the best scenario would be to have some sickle cell red blood cells and some normal red blood cells. Although malaria cannot grow in these red blood cells, individuals, blah, 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 I already read that, sorry. However, individuals with the heterozygous condition have some sickling of red blood cells, but generally not enough to cause mortality. In addition, malaria cannot survive well within these partially defective red blood cells. Thus, heterozygous tend to survive better than either of the homozygous conditions. All of that is interesting and great, but it doesn't have anything to do with solving this problem. Okay, just like any word problem that you have in math, you've got to filter out the important information from the fluff. So here it is, the important information right there. If 9% of an African population is born with a severe form of sickle cell anemia, that means that they are homozygous recessive. What percentage of the population will be more resistant to malaria because they're heterozygous? So what have you been given in that problem? Your Q squared. Your Q squared is 0.09. So in order to calculate Q, you got to take the square root of 0.09. So somebody in here who's got a calculator, do that for me. Oh, yes. 0.03, right? Or just 3? Yeah. See, there I go with stupid math. Okay, 3 times 3 is 9. I know that, but when there's the decimal there, I got it confused. So, oh, sorry, my child. Okay, so it's 0.3. Yeah. Why did you tell me that? I had it right. There? Yeah. Okay. Okay. So if I've got my Q, now I want to do my P. So I know P is going to be 0.7, right? And you don't have to calculate anything else except for the 2PQ. 2 times 0.3 times 0.7. 7 times 3 is 21. 0.21 times 2 is 42. Da, da, da. 42%. Got it? Oh, I see big smiles. So if you've been here and you've been studying these, you're going to do well on this tomorrow. And these are going to be so easy to grade because papers, when they're correct, are always easier to grade than when I see lots of mistakes. And hopefully, if you're tuning in and watching this at home, this helped a little bit. Bye.